All right, so this is going to be the fastest video I think I've ever done for y'all, but it's almost until 9. I got to get out of here. So this is a net. We've talked about nets when we talked about the Dandy Candies problem. And this is actually, if I fold here, 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 and here, and here, and I folded it back up, it would look something like this, not exactly. But we call this kind of a figure where there's rectangles on every face. It's called a rectangular prism, and it's a three-dimensional object. If I open it flat, this one looks a little different because I've got the end flaps at the end instead of over here, but it's still the same idea, okay? So this one has been opened up like this one and laid flat as its net, and we're trying to find the surface area, okay? So we want to find the area of all these rectangles. There's 1, 2, 3, 4, 5, and 6. All right, so just so you know that, to find the area, normally we'll be given, you know, lengths and widths and heights of everything, but since we've got the squares on there, we can go ahead and see them, so I'm just going to use those. So it says find the area of each of the 6 faces. Okay, now this face right here, the green one, is the same size as this one because it's just on the other side. All right, so this is 2, and we're just going to call it 2 units by 4 units. So this one's also 2 units by 4 units. So when we go to find the area, okay, there's always going to be in a rectangular prism 2 of the same thing. So we really only have to find one area. Okay, I'll put surface area here. So I can take 4 times 2, and that makes me see, whoop, it's not 4, I'm sorry, that's a 3. 3 this way, 4 this way. That means there's 12 squares inside there. So that's like saying I have 3 units times 4 units. If it was feet, you'd put feet there instead of units. And I get that area, and there's 2 of them. So I'm going to double that. All right? Plus, then I can do this area here, the 2 sides, and it's a 2 by 1, 2, 3, 4 also. So we can say 2 times 2 units times 4 units. And that's going to give me 8. So there's 8 and 8. That's why I'm doubling it here. Plus, I've got another rectangle at the top and bottom, and that's going to be 2 by 3. And this one's 2 by 3. So plus 2 times, I'm sorry, I'm kind of going sideways here, 2 units times 3 units. All right. Now, you could have done each one of these separately and done 3 units times 4 units plus 3 units times 4 units. I'm just doubling it, so I don't have to add all those together. But we have to add all of these areas together to get the total surface area of this rectangular prism. So very easily, that's 2 times. Well, 4 units times 3 units would be 12 units. Units times units is units squared. If it was feet times feet, it'd be feet squared. And look, we've got squares in there. All right, plus, then we're going to take 2 times. 2 units times 4 units is 8 units squared. That's this one and this one here. And then plus 2 times 2 units times 3 units. That means we've got 6 unit squares. So now we're going to double each of these. So that's going to be 24 unit squares plus here we've got 16 unit squares plus here we've got 12 unit squares. And then we just add all those areas together. So 24 and 16 is 40 units squared plus 12 units squared. And add those together and you get 52 unit squares. So if you counted every square on this whole thing, you would get 52. So that's the first problem. Okay, so that's what all of this is basically saying. And we got the notes right there. You can pause it if you need to. Then it says, explain how you can find the surface area of a box. Well, basically, I just showed you right there. Okay, then it says, describe the net of a cylinder such as a juice can. All right, so we know a juice can would look something like this. If I have it like that, it's a 3-dimensional object. It's got a circle for the top and the bottom, and then around the sides, if I cut that and open it up, it's just a rectangle. So there's my net. Okay, so if I look at the net, and you can go ahead and draw this too. There's the top, and there's the bottom. And I want to get the surface area of this whole thing. Okay, well, what I would have to do, I would have to find, to get the total surface area, I would find the area of one of these circles, and I would double it because I have two of them, and then I would add on to that the area of this rectangle. Let's put RECT. So to get those areas, okay, the area of one circle is pi r squared. All right, so pi times the radius squared. And we haven't really talked about how to derive that formula. If we have time, I'm going to show you at the end. It's really kind of cool. But for now, you've got a formula sheet, and that's on there. So the area of these circles, pi r squared, and then we're going to double that because there's two circles. Plus, we have to find the area of the rectangle. Well, the area of the rectangle is going to be the height of the can. Okay, so if I look at my juice can right here, wrap it around, there's the height right there. Okay, so whatever the height is, I'm just going to put h. Okay, then we've got to find the length here. Okay, now the length from here to here, how do we find that? Well, if I wrap, let me put that down in my mouth. Okay, if I take this rectangle, it wraps perfectly around the circle. Well, what's the distance around the circle? Circumference. So this length right here is the circumference of the circle. So that's going to be then the height times the length, which is the same thing as circumference of that circle. So it's going to be height times circumference of the circle. Well, how do you find circumference? Well, the other day when we did the lab where you all had to link your arms together, we know we can find circumference by taking pi times the diameter of the circle. So then we multiply it by the height, and then we add on the area of the two circles, pi r squared. Okay? So that would be the way I would find the surface area. Now I'm going to do an example for you. So if you turn your notes over, make sure you've written this down. You can pause it if you need to. Turn your notes over, and I've got this problem down or on the other side of your notes. And you guys, hopefully you've already read it. If not, pause the video and read it. And then I'm going to go ahead and draw a picture. So we're trying to find the surface area of a can, and I've already got this drawn for you. I called home because I couldn't find a can around here. And I had my husband and my son, they measured it for me. So we know the height of the Coke can, and I already put it in the notes, or in the word problem for you, is 12.3 centimeters tall. And then we know that the diameter of this Coke can, we said, was 5.2 centimeters. And we got to find the surface area. So if I open this thing up and look at my net, there's my top and my bottom, so it's going to be the same thing, but now we have real numbers. Okay, so we're going to start out to find the total surface area. We're going to do 2 times the area of the two circles. So the area of the circle is going to be pi times the radius squared. Well, the radius, if I divide this by 2, divide diameter by 2, I get radius. So 5.2 divided by 2 is 2.6. So I'm taking pi times 2.6, and then I'm going to double it. So that's going to give me the area. Oh, and this is centimeters here. Okay, so I'm going to do that one. And then I'm going to add pi and then the radius squared. So I'm going to take this thing, and I have to square it, and then I've got my parenthesis. That looks terrible. Let me do that again. Okay, so it's pi times the radius, which is 2.6 squared, and then that's all together. So I have to do this inner first. So then I'm going to add to that the height, which is 12.3, and I'm going to multiply that times, I got to find the circumference around this circle, which is the same thing as from here to here. So that's going to be pi times the diameter of the circle, which we found out was 5.2. All right, and the 5.2 is in centimeters, and this 12.3 is in centimeters. That's going to be important as well. And this is 2.6 centimeters right there inside with the 2.6. So now I'm going to simplify this part. So 2.6, I'm going to take that and I'm going to square it. If you do that on your calculator, you get 6.76. And then we're going to take that times pi, and then we've got to double it. Now when I square 2.6, I also square the centimeters. So that's 6.6 centimeters squared, plus we still have the 12.3 centimeters. And then we've got pi times 5.2. And I didn't do that yet. We'll do that all together here. All right, so on your calculator, when you take pi times 6.76, and you want it to actually give me pi, all the way out to as many digits as your calculator will hold, you're going to push the pi key, turn it on first, okay? And when you push the pi key and you multiply it times 6.76, you get 21.3 or 237 blah blah blah. We're going to round it to the nearest hundredth, so 2.4, and then we'll have to double that. Now you may say, well, Ms. Stevens, when I do this on my calculator, it gives me 6.76 pi as the answer. Okay, go to your mode key. Okay, once you go to your mode key, you're going to arrow down to where it says classic, and then it says math print. You're going to arrow over to math print and hit enter. Okay, and then that will get pi as 3.14159.265, blah, 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 blah. Okay, so now let's go back. And now we're going to do 12.3 centimeters. But first we're going to take 5.2 times pi. So you're going to do pi times 5.2. And you're going to get 16.336, blah, 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 blah. I'm going to make that 16.34, round it to the nearest hundredth. Okay, now this already is centimeters squared, because remember I squared that earlier. All right, so now we're going to take 2 times 21.4, or 21.2, so that's going to be 42.4 centimeters squared, plus, now I'm going to take 16.34 centimeters, after I multiply it by pi, times 12.3 centimeters. And when I do that, I get 200.94 something, but I know it was 3 something and it rounded up to 4. Okay, now it's centimeters times centimeters, so that's centimeters squared. Now all I have left to do is take the area of this rectangle and the area of these two circles, which I already did both of that, then add them together, so I get 243.42 centimeters squared. So tomorrow you'll come in and you're going to have a handout where you'll have to find surface area of cylinders and rectangular prisms. See you tomorrow.